Good day to all the viewers. There is a channel called World of Competitive Chemistry. On that, you can find various levels of chemistry which are related with the entrance and the competitive exams as well on the international floor if you are aspiring for. In addition, India is conducting CSIR NET exam in the field of chemistry. For the lecturership examination, most of the previous years, all the question papers are available over there, and brief description about engineering, chemistry, all the topic wise content is available over there, and the entire 10th standard physics, chemistry together are available on the channel. In addition, India level JE advanced, JE mains exams will be conducted for the admission into IIT and NIT stream. The previous year series of sessions are available on this channel, and NEET chemistry will be conducted all across India. NEET exam will be conducted once in a year. So that kind of sessions also covered over there with related chemistry. And the MCET exam previous year questions also covered with the detailed explanation with the authentic information. So all kind of quality information you can find upon the channel World of Competitive Chemistry. Right. So in addition to all these, whatever sessions we covered can fetching for your competitive exams, you're preparing for any government related job aspirations are there. In that also general studies, question paper, general science content you can crack. So let's enter into our today's session. The Nobel Prize in the field of chemistry in the year 2008 was awarded jointly to Osamu Shimomura, Martin Chalfie, and Roger Cyan for the discovery and development for the green fluorescent protein called GFP, right? So here, how many scientists are there? Osamu Shimomura, Martin Chalfie, and Roger Cyan. These three scientists accorded with the prestigious world recognition called the Nobel Prize in the field of chemistry for the year 2008 for the development of green fluorescent protein GFP, right? These are the scientists which are recorded with the 1/3 of each contribution towards the Nobel Prize. Osamu Shimomura, Martin Chalfie, and Roger Cyan together accorded with the Nobel Prize, right? Let's see what is the brief info regarding these three eminent scientists, right? So Osamu Shimomura belongs to Marine Biological Laboratory, Woods Hole, USA, and the Boston University Medical School of USA, right? Martin Chalfie, Columbia University, New York, United States of America. Roger Cyan, Howard Hughes Medical Institute, University, California, San Diego, Lazula, United States of America. These three scientists together explorated the discovery and development of green fluorescent protein GFP, so that this is accorded with the Nobel Prize. Glowing proteins are guiding star for biochemistry. In the field of biochemistry, the kind of protein, why it is called a glowing means fluorescent materials are having lighter, glittering nature. A remarkable, brightly glowing green fluorescent protein, GFP, was first observed in the jellyfish, Aquaria Victoria, in 1962. It is a kind of pigment they noticed, being it is the fluorescent protein which is naturally inbuilt in a jellyfish called Aquaria Victoria, that was first ever observed in the year 1962. Since then, this protein has become one of the most important tools to use to contemporary bioscience. With the aid of GFP, researchers have developed ways to watch processes that were previously invisible. So there is a kind of technology we are imbibing. We are diagnosing. It is used as the diagnosing technique. Okay. So by means of this fluorescent dye, whenever we are inserting into the body, along with the fluids, the dye also moving, so that we can visualize what will be the movement of that one, and if any fluctuations, obstacles observed in that path, so that they can notice any kind of damage, any sensitive rupture, any kind of abnormality that can be understood. This is the kind of diagnostic technique where the pigment, fluorescent pigment or fluorescent protein can be inserted, so that we can observe, we can identify where the kind of abnormality we can have. such as the development of nerve cells in the brain or else in the cancer. Wherever cancer cells are spreading, there you can go for the monitoring by means of this fluorescent protein, or else development of nerve cells. So even in the nerve cells, how the nerve cells are developing, that also can be observed over there, and even brain functioning can be analyzed by means of these fluorescent proteins, which is very complicated to understand by normal means. Tens of thousands of different proteins reside in a living organism, controlling important chemical process and a minute detail. If this protein machinery malfunctions, illness and disease often follow. That is why it has been imperative for bioscience to map the role of different proteins in the body, right? So here, different kind of proteins are available inside, so that whatever activity is there, exactly knowing about individual activity of each and every protein is very difficult to process, being all the metabolic functions and kind of systems available are very complex in nature, so that 100% analyzation may not be possible. So that is the kind of there is a vacuum in that research. Story behind the discovery of GFP is one which three Nobel Prize laureates in the leading roles. Osamu Shimamura first isolated GFP from jellyfish. First of all, it was taken from the jellyfish and observed. So being it is a glowing one, that is a kind of fluorescent material, Aquaria Victoria, which drifts with the currents of the west coast of North America. He discovered that this protein glows bright green under ultraviolet light. If light strikes on the pigment, what happens? Immediately it will glow. So that glowing tendency can give the highest visualization tendency, highest easy visualization tendency. That's the reason why it was taken into the concept of research in order to synthesize in the laboratory. Martin Chaffee demonstrated the value of GFP as a luminous genetic tag for the various biological phenomena. That was taken as a biological tag in order to introduce into the biological phenomenon and how it can be imbibed. That kind of genetic tag, kind of a new version for that pigment, whatever they abstracted. So he explorated upon. In one of his first experiments, he colored 6 individual cells in the transparent roundworm. This is the kind of a Keanu Robbins elegance with the aid of GFP, right? So green fluorescent protein is abbreviated as GFP, where so here 6 individual cells were taken and transparent roundworms will be taken into that kind of a dish. In that, so they got colored with these GFP pigments. GFP proteins are inserted onto their surface. So that kind of experiment was done by Martin Chaffee. Robert Sion contributed to our general understanding how GFP fluoresces. He also extended the color palette beyond green, allowing researchers to give various proteins and the cells different colors. This enables scientists to follow several different biological processes at the same time, right? What Roger Sion did, so he contributed general understanding, what is the tendency, what is the mechanism behind how it is flourishing, how it is how it is giving the brightness. Okay, that kind of studies got carried by this Roger Sion. He also extended color palette beyond green, allowing researchers to give the various proteins and the cells different colors. So in general, natural source, they collected from the jellyfish the green color pigment. Apart from that, some other colors also can be extended, can be grown. So that creativity part also taken by this Roger Sion. So this is about the contribution regarding this GFP protein invention. So this protein invention, not only the kind of new thing, rather it is the kind of a great application we can say, because let me give the simplest example. In order to analyze the heart functioning, we will go for the diagnostic method called the angiogram. based upon dye moment, speed or velocity of dye only, how the functioning and how the nerve cells are working, entire thing will be analyzed. If you're not able to moving forward, that indicates what there is a kind of block in that. Okay, so wherever you're moving, so wherever you're working, so that the pigment may not move forward. So that is the kind of diagnostic tool they developed. So that is a fluorescent protein. It is most valuable invention in the field of medicine, which gives the kind of identification of so many type of dready diseases, we can say. Even brain functioning clearly analyzed by means of these proteins, so that we can easily understand how that brain functioning will be there, which can't be imagined or which can't be captured by means of other kind of diagnostic tools. This is the way Nobel Prize in the Chemistry 2008 is given for the fluorescent protein invention, right? Let's go with the question number 2. Question number 2 collected from Cambridge International Assessment, and where we have a table and solutions of J, K, L, M are provided over, and they are given with the colors. Whenever it is in contact with the universal indicator, different solutions are contact with the universal indicator. J solution is able to provide a green color, K will provide a red color, L will provide a purple color, M will gives rise to a orange color. If this is the condition, among these many solutions like J, K, L, M, which are categorized as acidic, based on the color appearance, we have to identify which are called acidic in nature. Among J, K, L, M, you can identify K and M are the category of acidic. How can we say? You can clearly identify acidic or red color is the kind of what universal indicator pH range will be 4. Orange color will be a 5, and a 6 will be for yellow. All these three together are regarded as acids. And 7 being neutral, so here universal pH indicator 7 gives a neutral one. From 8 to 9 to 10, you can notice intense green color and sky blue color and navy blue color. All these together are regarded as bases on universal indicator color change. So by taking this concept into the mind, you can clearly identify red and orange are the part of acidic. Red and orange are the part of acidic, and M are designated as acidic solutions. Let's move on to another question. Question number 3 collected from 2016 J advanced question paper 1 question it is. For the invert sugar, the correct statements are: specific rotation plus sucrose plus maltose, L minus glucose, and L plus fructose in the aqueous solution plus 66 degrees, plus 140 degrees, minus 52 degrees, plus 92 degrees respectively. All these are called what? Specific rotation values, right? So invert sugar is prepared by acid catalyzed hydrolysis of maltose. Invert sugar is prepared by acid catalyzed hydrolysis of maltose. Maltose gives rise to the invert sugar. Whether it is correct or not, we have to check it out. Invert sugar is an equimolar mixture of D plus glucose and D minus fructose. This is perfect answer. Specific rotation of invert sugar is minus 20 degrees. On the reaction with bromine water, invert sugar forms a saccharic acid as one of the product. So among these, the correct answers are only B and C. A and D are wrong one. Let's see. Invert sugar is prepared by invert sugar, also known as invert sugar syrup. Invert syrup. This is a liquid sweetener made from the granulated table sugar and water. Whenever table sugar was taken, that is called a sucrose in a chemical sense. Added with water so that it will be hydrolyzed. Whatever solution coming out after hydrolysis is said to be an invert sugar. Table sugar is a compound scientifically known as a sucrose. It is formed when one of the sugar molecule called glucose chemically binds with another fructose molecule. The combination of glucose with fructose, then only you can get the dimer called the sucrose. Inverse sugar created via hydrolysis, a process in which sucrose is mixed with the water, heated until bond between the glucose and fructose broken. Enzymes or acidic ingredients like citric acid, cream of tartar can be added to expedite the process. D plus glucose and D minus fructose are the isomers commonly available in monosaccharides. The ratio of conversion D plus and D minus fructose glucose isomerase is required. The combination of these two is giving rise to the table sugar. Whenever table sugar got hydrolyzed, so that you can achieve D plus glucose and D minus fructose respectively, right? The specific rotation, another term we gone through is a specific rotation. Obviously, glucose is of dextrorotatory, so that it is indicated with the positive sign in front, so that it will show the clockwise rotation and possess this 52.5 degrees of specific rotation for glucose. But fructose strongly levorotatory, having anti-clockwise rotation whenever kept in a polarimeter, so that negative 92 degrees is accorded for this fructose molecule. While inverting, the specific rotation gradually undergoes a change in direction of polarized light from 66 to minus 19.7. Okay, whatever specific rotation we have for these two molecules, whenever we are mixing up these two molecules together, so that initially you can achieve the plus 66.5. As time passes, so that slowly it will be running down and reaches the value minus 19.7 degrees. Minus 19.7 degrees, you can round it up as a minus 20 degrees inverse sugar specific rotation. That is the fine answer for this question number 3. And let's go with the bromine water reaction and the invert sugar. Whenever invert sugar is treated with the bromine water, obviously glucose will be treated, being aldehyde is at the topmost. Aldehyde will be bromine water as a mild oxidizing agent, so that aldehyde will be converted into carboxylic acid, and else chain remains the same. Whatever chain is there, that remains the same, will not be reacted further. And that entire molecule with the topmost aldehyde into a carboxylic acid, that is designated as a gluconic acid, where aldehyde group gets oxidized to the carboxylic acid. Fructose will not be affected by bromine water. Why? Because fructose is a kind of ketone. Ketone will not react with the bromine water in under normal conditions. This is the way. This is the way. Bromine water will give rise to the gluconic acid rather than saccharic acid. You can cancel out this option D. And invert sugar prepared from glucose and fructose, but not by the maltose. So strike up this as well. Only the possibility is invert sugar having equimolar ratio of D plus glucose and D minus fructose is correct. Specific rotation invert sugar initially plus 66. After as the time passes, it will reach as minus 20 slowly, and it will be stable, right? By this, we concluded the question 3. Question 3, correct options are B and C. Let's move on to question number 4. Question number 4 is collected from organic chemistry point of view. A treatment of the compound O with KMNO4H plus gave P, which on heating with ammonia gave Q. The compound Q on treating with bromine NaOH produced R. On strong heating, Q gave S, which on further treatment with the ethyl 2-bromopropanoate in the presence of potassium hydroxide followed by acidification gave compound T. Right. So these many series of reactions are started with the compound O. O is known to you. That what is that? So this is a kind of benzene ring. On this benzene, how many carbon chain? 1, 2, 3. Here also 1, 2, 3. 1, 2. Propyl. So both are propyl chains only. Propyl benzene. 1, 2 propyl benzene will be taken as a starting material. And KMNO4, what is the role of potassium permanganate under acidic conditions? That is the strong oxidizing agent. Whatever the length of chain, you may take 1 meter or 1 kilometer, that will be Oxidized to gives rise to the carboxylic acid only. Though it is the 3-carbon chain, 1-carbon chain, 4-carbon, whatever. Irrespective of the chain length, whatever chains are present on this side chain of the benzene, by the action of caminophore or else K2Cr2O7, both are strong oxidizing agents, so that you can accord carboxylic acid. So here carboxylic, here carboxylic, that is called phthalic acid. The phthalic acid is the compound P you can achieve. Phthalic acid upon reaction with ammonia. You can go with the ammonia, sorry, ammonia reaction. Carboxylic acid, ammonia, acid-base reaction, so that we will get amide linkage. So that diamide will be originated, called Q. The Q will be treated with bromine water. This is called Hoffman reaction. Hoffman hypobromite reaction. So here NaOBr will be generated. NaOBr is more specific for the conversion of amide into amine, because CO will be disappeared and that there is a generation of NH2 as the functional group. So that will be R. So till here we will discuss this. Next part will be covered in the next session, because this is another question we will go with. Up to product R only we have to go for today's question, right? Let's see. This is the expected answer, where NH2 and NH2 are adjacent carbon atoms, which is called anthranylic acid. The expected answer. So this is called what? 1,2 dipropyl benzene will be taken as a starting material, and so many reactions got carried, and finally anthranylic acid is achieved as the final product R. Let's see what are the series of reactions. Initially, benzene, alkyl benzene, we can say dialkyl benzene, which is said to be 1,2 dipropyl benzene. 1,2 dipropyl benzene is a starting material, treated with strong oxidizing agent caminophore under acidic conditions. Entire alkyl chain got oxidized to carboxylic acid, so that we can achieve phthalic acid. Phthalic acid is a dicarboxylic acid and the aromatic ring. Move on to ammonia. Ammonia, when added, what happens? Acid turned into a amide linkage. These two amides will be originated. Now, reaction with bromine NaOH. This bromine NaOH is giving rise to the NaOBr sodium hypobromite. That sodium hypobromite is a Hoffman reaction, which selectively removes the CO, and you can achieve NH2 here. That is called the benzene 1,2-diamine, which is said to be benzene 1,2-diamine is the IUPAC name. IUPAC stands for International Union for Pure and Applied Chemistry, and this is simply called anthranylic acid. This is the expected product you can achieve in the option A. This is the way question number 4 got answered. Move on to question number 5. It is collected from the IMSET examination conducted by Telangana in the year 2022. Aluminum metal treated with aqueous sodium hydroxide and the P and Q products are obtained. What are P and Q? Okay. Metallic aluminium upon reaction with sodium hydroxide, P and Q will be obtained. There will be the products. Always remember what common thing for all the metals are, whenever metal is treated with either acid or else base, always there is a liberation of hydrogen gas is the common one. So that here alkali, sodium hydroxide is called purely alkaline solution called basic, and aluminum is a metal, so that there is a liberation of hydrogen. If you observe all the options among 4, only the option with the hydrogen is 3, so that you can put tick mark over here without knowing the chemical reaction. This is the hint hidden here. Always remember, any metal upon reaction with either acid or base, that gives rise to the hydrogen gas as the one of the product, so that hydrogen liberation indicates this is the reaction. Remaining options are not valuable with the hydrogen gas. And one more product is called sodium tetrahydroxy aluminate. And moreover, you have to put on aluminate 3. This is the way the product will be generated. Let's get the clear explanation for this reaction. Sodium hydroxide, aluminum metal under aquated conditions. So if we are going to treat up, sodium aluminate will be generated with the liberation of hydrogen gas. This is the way reaction can be explained. For question number 5, option number 3 is the correct answer. Let's move on to question number 6, the last question of the session. Among the following elements, X exhibit maximum catenation and Y is the least abundant on the earth. What are X and Y? Most of the people are familiar for the catenation. Catenation is nothing but if you are able to generate the long lengthy chain with the same repeated atoms, repeated element, that is called a catenation. If you go for lithium, monoatomic only, so there is no such kind of lengthy, rather it able to exist in that lithium only. If you go with beryllium, beryllium compound itself is not the polymeric, rather beryllium chloride is a polymeric in nature, right? But if you go for carbon, carbon able to combine with any other carbons in that lengthy chain, you can go for a meter, kilometer, and beyond that 100 kilometers, that extent also this carbon able to increase its chain length. That is called its a catenation property. Catenation denotes as any element having its own binding with the same elements in order to increase the chain length is called a catenation. Binding ability of that element within, right? That is called catenation. And why? Y is a kind of least abundant. So least abundant element to be depicted. So here, obviously carbon is the kind of, just now we gone through, among the entire periodic table, carbon is the element with the highest catenation property, so that the options with the option 1, option 3, option 4 are having carbon, so that you may have the chance to depict the answer either 1, 3 and 4. You can cancel out to 2. 2 is the example for semiconductor. Silicon, germanium are the class of semiconductor, so that discard this one. Only the probability of after option 1 and option 3, option 4. So that catenation is the property by which carbon atom can bond with the number of other carbon atoms to form the straight chains, branched chains, ring systems of a high tendency to carbon to catenate because of high carbon-carbon bond strength. Okay, carbon atom having such a peculiar nature because it able to generate so many kind of bonds with their carbon atom in order to get the lengthy polymeric chain. Lengthy chains are possible, either it may be a straight chain, a linear one, or else a certain branches may exist, or else entire molecules get combined, gives rise to a ringed one, ring type of structures also available, so that this is the property purely belongs to the unique element called carbon. Move on to another question, another half of the question called germanium. Germanium abundancy is extremely less in the entire elements whichever occurred in the earth crust. So that least abundant element in the earth crust is designated as the germanium. 1.6 ppm is its abundancy. It is very tiniest quantity, lightest quantity. Earth's crust is approximately 1.6 ppm is accorded for the germanium abundance. Only few minerals like argyrorite, briartite, germanite, renierite, and sphalerite. All these are the kind of minerals where we can achieve the germanium in the extractable quantity, right? So these are called the minerals, but extremely lesser quantity availability, that is 1.6 ppm is accorded. So that together you can mention carbon and germanium are the correct answer. Carbon symbolizes the catenation property, and germanium symbolizes the least abundant element on the earth crust. This is the way question number 6 is answered with option number 1. By this, we entirely completed the session and successfully achieved the content related with the intermediate level chemistry on the competitive floor. Definitely, who are watching, who are more curious about the examinations, either it may be entrance or competitive, so that you have to go through the entire work whichever we are going in the world of competitive chemistry. So many series of sessions got carried, and detailed informative sessions are uploaded over there. Around 470 videos are available over, and much more information is with you. Only the thing is you have to spend your valuable time and get the notes and repeat the sessions for several times so that the content will be more familiar for you. Definitely you will crack whatever exams you're aspiring for. Wish you all the best, and sincerely requesting to like the channel, comment. In order to comment, there is a question for the session. If carbon is taken into the consideration, how many type of naturally available compounds you know which are composed by the carbon? How many naturally occurring compounds are known to you which are composed by the carbon? You can put the comment in this comment box for the session and share with us parents who are more serious about the examination, and subscribe the channel so that we will get more quality content in the near future. Definitely every day the content will be uploaded so that it is a kind of a high information, high impactful session, we can say, right? Thank you for watching.